Hi again. What we have done, let's examine this now. We were dealing with the first order circuits and we found a mathematical model of it and give a special name for it. This is state equation. If it is first order, that means one inductor included or one capacitor included circuit we are talking about. And for this circuit, find a solution. There are two alternatives. Use the mathematics. Use the physical based mathematics, let's say, two solutions. In these two solutions, in mathematical one, we're going to find the homogeneous solution as we found here, and then find the particular solution, add those up, find the general solution. This is what we have already examined. And then we said there is an alternative to this, saying that by using the superposition, I can consider the given circuit, this given circuit here, that's the given circuit here, has got two energy sources. One of them comes from that VST, that is independent voltage source, and the other one comes from that initial condition. The corresponding energy to this initial condition is 1/2 times L times initial condition square. We have already done this. So there are two energy sources, or the two power sources you might say. We know that from the superposition, if we found for each source's related current for an element, when both of these sources are in, the solution is the summation of the previous one of the source included circuit solutions. What I mean is this. When this voltage source only included in the circuit, or let's say the opposite around, if this energy source is 0, that means initial condition is 0. If initial condition is 0, then the solution that you're going to find is going to be like this. What I said, when the initial condition in and the independent voltage source off, that means independent voltage source voltage becomes 0. So the solution that we found when the initial condition in is called particular solution, natural solution. Why it is called natural solution? Because this source is on the circuit. This source is outside the circuit, isn't it? Consider a TV circuit, TV equipment that you have in your house. You're going to connect the TV to a wall out the energy source on the wall, isn't it? So that means that energy source outside of the TV equipment. That's why it is, if this energy source outside the TV equipment is forcing the TV to run in a way, that's why we call it forced solution. So we already found the natural solution. Now we're going to find this forced solution now. What it means, let me explain it in here rather than there. So this is the circuit given to us, and we are saying now we are going to find a forced solution when the initial condition is 0. Here you are, initial condition is 0 and the source is end. So if I come back to this, here you are. So that's the original circuit given to us. Original circuit, let me write it right. Original circuit. Now we are saying make the initial condition equal to 0 and keep the independent voltage source in. The solution you're going to find is called forced solution. This is the one that we are going to examine now. If we consider the other energy source, that means initial condition, that condition, and make this independent voltage source inactive, that means make the voltage is equal to 0, and a resistor here, and an inductor here. And that inductor has a initial condition EL0, which is 0.5 amp. And we've got resistor here. This solution is natural solution. So in Turkish this is called öz çözüm. So we said we already found that. We are not going to do this one. And we are going to examine this one now. This is we already examined. And we are saying, by using this superposition, the solution that I found, which is called natural solution, if I sum them with the fourth solution, I am going to get the original circuit general solution. General solution is going to be equal this force plus natural. So in this explanation, I will be dealing with only this fourth solution. So let me transfer this fourth solution here now. We are dealing with fourth solution. So this case. So our differential equation, which is called the state equation, is this: d ILT over dt is equal minus r over l ILT plus 1 over l Vs. So what I am going to do, whatever we have done in the mathematical solution, so I'm going to find, let me change the color now, make it black. I am going to find a homogeneous solution. And then I'm going to find a particular solution, add those up, give the general solution. This solution, in this solution, what's going to be the difference between this one and the first solution? In the first solution, I am going to consider the initial condition equal to 0. In the mathematical solution, I was using this initial condition. That is the only difference. So homogeneous solution is the solution when the known function is equal to 0. So it is, the solution is IL over dt minus r over l IL. So we are estimating, in this case, IL general homogeneous solution is equal to C times e to the power minus r over minus s. I made a mistake. Maybe I have written here e to the power st. So we are going to calculate two parameters here. Maybe I already use alpha, but this time I have used s. So if you calculate the s, we have already done it, so I'm going to say it a bit rapidly. So you're going to put this one in the equation, get the derivative of it, make the left hand side equal to the right hand side. You're going to end up with s is equal minus r over l. How I found that is exactly the same as I found this in the mathematical solution, general solution, homogeneous solution, sorry. So my homogeneous solution becomes now IL equal C times e to the power minus r over lt. So I found one of the parameter, keep the other parameter here, because I will be calculating this parameter at the end by using the initial condition. Now in this time, this initial condition is going to be this one. Make it a bit different color. And so I'm going to calculate this one after I have found the solution by using this initial condition. So this second step, that's the homogeneous solution. Second step, find a particular solution. We learned alternative particular solution calculation when the source is DC. So in here, in our example, VST is equal 100 volts. So if Vs is 100, so it is the DC source. So how I'm going to find a particular solution? I am going to use the definition of, I know particular solution is the solution in the form of independent source. So particular solution is going to be IL equal a constant. So IL constant, I said, this is particular solution. So on the other hand, I know that definition relation of the inductor is VL equal L times I dIL over dt. Since IL is a constant, derivative is 0, so VL equal to 0. If VL equal to 0, then that means short circuit. What is short circuit? This inductor is short circuit. So my circuit becomes this. So I am looking for this current, and this current is going to be my particular solution. What is this current? In this, so the resistor of that, this resistor voltage is the same as source voltage. So that means the resistor current is also equal to this current. So that means IL is the same as the resistor current. Then it's going to be IL particular is equal to Vs over R. So if I add those two, IL general solution is equal C e to the power minus R over L T plus Vs over R. This is the general solution. Now I will be using initial condition to find that C out. So this initial condition is going to be this initial condition. So let me do it. I'm trying to find this. So the only thing which is not known here is that C. I said I will be calculating it later on, so I am doing it. So if it replace t equal to 0, so then this becomes IL 0, which is equal to 0, is equal C times e to the power t equal to 0, that means e to the power 0 gives you 1 plus Vs over R. Then from that I can find that C is equal minus Vs over R. So if I replace that C value in here, my IL forced solution is equal minus Vs over R e to the power minus R over Lt plus Vs over R. So you can put this in Vs over R parentheses, of course. but I am keeping it as it is. So what we have done here, we have found T partners force solution. The only difference, calculating of that C is based on the initial condition equal to 0. If I were considering the first original given circuit general solution, I will be calculating that C by using that initial condition. Now I change it, use this initial condition which is 0, then my solution becomes force solution. So where we can use it physically, this force solution, you can say that if the original circuit is given to you like that, so you can divide this solution as two other solutions summation. One of them is force solution, which is this one, and this natural solution that we have already found. If you add those two up, you're going to get the original circuit general solution. So you can compare now this solution with the mathematical solutions that we have already found. So we will be doing it next. Maybe from that we could say some other things as well. So if you come here, let me. So we explain to you this force solution now. So I have done it as I do it on board in class. So if you put the numerical values, you're going to get these values here. So our general solution becomes natural solution plus the first solution. In the natural solution, you see that Vs equal to 0, initial condition is 0.5 amp. Force solution, the independent voltage source in, but initial condition equal to 0. So that is the end of this video then. So stop it.